Hi, I'll be going over the umpire process for square root x. So the first step is understand. So for our input, we're given a non-negative integer, x. So let's write that non-negative integer. Then for our output, you want to return the square root. Square root rounded down to the nearest integer. So for example, if we're given 4, then our output should be 2. And if we're given 8, our output should also be 2. So in terms of matching, I think I might have seen this problem before or something similar. The first thing that came to my mind was probably using like a brute force solution. Like we probably use like a loop, and then we check if every number that's less than that number is like greater or isn't greater than the number we're given. Then yeah, we'd probably do something like that, some sort of like loop like that. But I think what would be better if is like since we're looking at like sorted numbers, we actually just like use binary search. I think this would be more efficient, and it'd probably also use like less space too, I think. So in terms of the planning, so we want to create our left and right pointers, and then we also will create a result variable, just in case like we exit our loop, we'll still return the correct result. And then we'll use a loop that goes from 0 to our given number, and then we'll get the middle element or middle number. If that middle number is greater than our given number, we'll update our right pointer. If it's less than our middle number, it's less, then we'll update our left pointer. If it's less than our middle pointer, we'll update our left pointer, and then we'll also update results. Then otherwise, if I forgot, sorry, so we're not checking our middle number, we're checking our middle number squared. So we get the middle, if that middle number squared is greater than our given number, we update our right pointer. If it's less than our middle number, we update our left pointer, otherwise, and then we update result. Otherwise, if it's equal to our given number, we're not checking against our middle, we're checking against the given, sorry. So it's less than our given number. If it's equal to our given number, then you want to return, let's return the middle number. And then if we're out of the loop, so otherwise, if we're out of the loop, we just return our results, our result variable. Alright, so let's see. So now we're in the implement stage. Let's see how we would go about it. So we have left equaling 0. We have right equaling our given number. So right should equal x. Then we'll have result equaling 0 also. Then while left less than or equal to right, we'll get the middle. So middle equals left plus right divided by 2. And then we'll check. So if middle squared is greater than x, then we want to update right. So right should be equal to middle minus 1. Otherwise, if middle squared is less than x, then left should be equal to middle plus 1. We update our result to equal middle. Otherwise, we can just return the result, middle, sorry. And then if we're out of this loop, if like we reach the end, then we just want to return results. So let's check it. Nice. So yeah, we got both test cases. And I'll submit it. Nice. So it was accepted. Yeah, so I think in terms of evaluate, our space is O1. Yeah, we don't use any extra space. We don't create like any extra data structures or anything. So we use constant space. We use these variables, but yeah, we don't really create like anything extra. I think this is okay. And then for our time, I believe this is O log n. Alright, thank you. That's my umpire process for square root x.